Hello everyone, my name is Malcolm. Today I'm very happy to be here to introduce IEI's new AI Inference acceleration card, Mustang V100 MS8. V stands for VPU, and the MSA means there are 8 Intel Movidius Marionette chip inside this PCIe card. With Intel OpenVINO toolkit, you can serve on deep learning inference acceleration by Mustang V100 MS8. Before we introduce the new product, let's talk about why IEI decided this new product. As we know, IEI is a leading company of hardware design, and QNAP is one of IEI group company that has strong software capability. Due to the AI chip capability is getting stronger and AI algorithms getting higher accuracy than ever, we expect the AI demand will increase dramatically in the future. And that's why IEI cooperates with Intel to design AI acceleration cards, and in the meanwhile, QNAP invests lots of resources to focus on AI industry. From factory inspection, smart retail to medical assistance. There are more and more AI applications in our everyday life. But actually, AI is not going to replace human at all. We use AI to assist human because it never gets fatigued and will not affect its judgment by other undesired factors. And let's have some recap of AI process. In traditional machine learning, engineer and data science have to define the feeder of input image. For example, in this case, we have to create the feeder of ear, mouth, and the tail's appearance manually. Then it can predict the input image. In deep learning progress, we have to prepare the text training image. Use the suitable topology to train the model. The feeders will create automatically by the algorithm. In this case, deep learning starts to extract edge in first layer and get bigger regions such as nose, ear, legs in deeper layer, and finally predict the input image, which means a 90% loss in this case. And the main difference between traditional machine learning and deep learning are machine learning have to highlight the feeder manually by engineer and data science. Deep learning will generate the feeder by topology itself. The second difference is the more correct data will help deep learning to get higher accuracy. And that's why in recent years, deep learning methods can almost reach human eye judgment in the ImageNet contest. And this page includes deep learning tools frameworks, above OS. There is frameworks for deep learning such as TensorFlow, Caffe, MSNet. Then using the suitable topology to train deep learning model. Let's say for image classification tasks, you may select ASNet, GoogleNet. For object detection tasks, you may choose SST and ULO. And deep learning has 2 sections. One is training, another is inference. The text image generates trained model by designer a topology. Then output the trained model into inference machine to predict the result. The technology of training is almost well established in today's industry. But how to complete the inference process is the most important task today. So what is OpenVINO toolkit? OpenVINO is short of Open Visual Inference and Neural Network Optimization. And it's an Intel open source SDK, can convert popular frameworks into Intel acceleration hardware. And the heterogeneous feeder allows it can work in different acceleration platforms such as CPU, GPU, FPGA, and VPU. And it's also including model optimizer to convert pre-trained model from different framework to Intel format. And the inference engine is a C++ API which you can call API for inference applications. Besides, it also has optimized OpenCV and the Intel Media SDK to do the codec work. And here's the OpenVINO toolkit workflow. In the first step, it converts the frameworks by model optimizer. Then start by the left top corner video stream, because all video streaming was encoded, so it needs to be decoded by Intel Media SDK. Then it needs some image pre-processed to remove background or emphasize the image by some morphology methods in OpenCV. Then call inference engine to predict the input image. After the prediction, it will need image process, which means use OpenCV again to highlight the object you detect or add some text on the detect result. Then the final step is to encode the video, then send it back to the other server. And OpenVINO toolkit including many examples and the pre-trained models such as object recognition, image classification, and pre-trained model including age, gender recognition, vehicle detection, which you can download and get familiar with the OpenVINO toolkit interface from the Intel official website. And in hospital, there are many data can be analyzed by AI methods, such as OCT and the MRI image and other physical data from patients. And let's take a look by one example. In this example, macular degeneration would happen in senior citizens. Once you found you have the vision distortion, it might be too late for medical treatment. So in this case, it's using ResNet 50 to train 22,000 tag OCT image by medical experts. And it can predict weight and dry normal macular condition by AI method. We can see from the left-hand side picture is the deep learning application without OpenVINO toolkit. The frame rate is around 1.5 frames per second. And in the right-hand side picture is using OpenVINO toolkit. The performance is 28 frames per second, which is almost 20 times increasing in this application. And here is the IEI Mustang acceleration card series, including CPU, FPGA, and the VPU. VPU means Mustang V100 MSA. And they are all based on OpenVINO toolkit to implement to deep learning inference applications. The features of Mustang V100 MSA is a very compact PCIe card, which is a high head length and a single slot dimension. And the power consumption is 30 watts, which is extremely low. And the 8 Intel Movidius Mari-X VPU inside provide powerful computation capability, and it's ideal for edge computation. Other features are wide temperature range, which can operate during 0 to 55 Celsius, and it also support multiple cars and support the popular topologies such as SNAT, GoNet, SSD, and ULO. And another great feature of Mustang V100 MSA is the decentralized computing. It can distribute different VPU for different video input, and even different topology for each VPU, which is very high flexibility for your applications. Mustang V100 MSA supports topologies such as SNAT, GoNet is ideal for image classification. SSD ULO is suited for object detection applications. And here's a comparison table of FPGA and the VPU acceleration cards, which can help a user to choose what's the ideal card for their applications. VPU is ASIC, so it has less flexibility compared to FPGA. But with its extremely low power consumption and high performance, it's very suitable for edge device inference systems. And let's introduce IEI acceleration cards roadmap. CPU and FPGA acceleration cards are already launched, and the VPU acceleration card will launch in December. And more SKUs such as the mini PCIe and the M.2 acceleration cards interface will be ready soon. And here we introduce an ideal IEI system for AI deep learning. Flash BS200 is a 2U compact chassis with rich I/O and can connect to Flash PPC to become a IP66 high-level water and dust-proof system, which is ideal for the environment of traditional industry. And Tank IEI OT development key is an Intel-proof OpenVINO toolkit platform with pre-installed OpenVINO toolkit. It's an OpenVINO toolkit-ready key. Can develop your deep learning inference applications with IEI, VPU, and FPGA acceleration cards right away. And here's an example. In this demo, we are using Tank AIoT development key and the Mustang V100 MSA with OpenVINO toolkit to run an Intel pre-trained model of vehicle classification. And let's start the demonstration. And here we have the Tank AIoT development key and combined with our Mustang V100 MSA to process OpenVINO pre-trained model about the vehicle recognition. And in this demonstration, it's using GoogleNet and ULO to do the car detection and the vehicle model recognition. So you can see from the left top corner, the frame rate is around 190 and 200, which means this car's computation capability is extremely high. Mustang V100 MSA has the features about very low power consumption and also the very compact size, which is an ideal acceleration product for your edge computation device. That's today's demonstration. Mustang V100 MSA is the ideal acceleration card for the AI deep learning applications. Hope you can understand more by today's introduction and the demonstrations. If you have more questions, please contact us or scan the QR code to get more detail. Thank you. Bye.